everyone. Today I'm going to show you how to add fractions with different denominators. So that you have 1 over 2 plus 1 over 3. Again, when you add in fractions, the rule was to make sure that the denominators, the two bottom here, are exactly the same. Unfortunately, in this case, it is not. When it's not the case, what I want you to do is go on the side, write down the first denominator and write down the second one. The first denominator here is 2. So you're going to keep on adding the same number to it. So you're going to keep on adding 2. So 2 plus 2 is 4. Add another 2 to it, 6. And you keep on adding until you have enough numbers, and you can start doing the next one here, the bottom one here. Add 3 to it, because the first number is 3. Or if you go to your multiplication tables, you can just go ahead and multiply. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10, and so on. And then once you realize that you have two numbers that are exactly the same here, you can just stop, because this is what they call the common denominator here. And again, remember LCM when we're doing LCM in section 2.1. Now, the common denominator here is 6. That means what? That means I need to be able to change that 2 here into a 6. And I need to be able to change that 3 here into a 6. Now, how do I do that? What do I have to multiply this by? Always think in terms of multiplication when you're doing this. What do I have to multiply this by to get to 6? 2 times what? Again, it's 2 times 3. Even if you didn't know, just count the number of spots here. I have 1. 6 is in what spot? 1, 2, 3. So that's why it's 2 times 3. And what about this 6 here? How do you go from 3 to 6? You have to times this by 2. So 3 times 2 gives me 6. Or here, you can look at it here, 6 is in the second spot. So that's why we're multiplying it by 2. Now again, remember the rule. Whatever you do to the bottom, so if I'm multiplying this by 3 to get 6, whatever I do to the bottom, I have to do it to the top. And whatever I do to the bottom here to get the 6, multiplying it by 2, I have to do this also to the top. So now I had 1 over 2. Now it becomes 1 times 3, which is 3, and then 2 times 3, which is 6. Now it becomes 3 over 6. And here I have 3 times 2, which is 6, and 1 times 2, that is 2. Now they have the same denominator. What was the rule when they have the same denominator? You keep the denominator the same, and you just add the top. So we're just going to do 3 plus 2, which is 5. And that's your final answer. Let's look at another example. Let's say that you have 7 over 12 plus 3 over 8. Again, another way of setting this up, if you want, you can set it up that way instead. 7 over 12 plus 3 over 8. Again, what do we realize? We realize that the denominators are not the same. You have a 12 here and you have an 8 here. Again, go on the side so you can find a common denominator. So here we're going to keep on adding 12. So 12 plus 12 is 24. You add another 12 to it. You get 4 plus 2 is 6, 2 plus 36. Again, your numbers are already getting so big here, so you need to start adding some 8 here. So 8 plus 8 is 16. 16 plus 8 is 24. And you can stop once you realize that the number here, you can see it there also. So this is the common denominator. That means what? Your goal is to change that 12 into a 24, because that's what the common denominator comes out to. And your goal is to change that 8 into a 24 as well. But again, in order for you to change it, you always need to think in terms of multiplication. 8 times what will give me 24? And 12 times what will give me 24? Again, it's going to be 12 times 2. Reason again is because the 24 here is in the second spot for the 12. So 12 times 2. Here it's going to be 12 times 3 because 1, 2, 3. The 24 is in the third spot here. Or it also is because 8 times 3 is 24. Now whatever you do on the bottom, I multiply the bottom by 2 to get 24. I have to do it to the top. I multiply the bottom here by 3 to get 24. So I have to do it to the top as well. Multiply by 3. 7 times 2 is 14. 12 times 2 is 24. Here, 3 times 3 is 9. 8 times 3 is 24. Now what do we have? We have the same exact denominator. So we can add now. When you have the same denominator, the denominator stays the same. and we just add the top, the 14 with the 9. And then 14 plus 9 give us 23. So your final answer is 23 over 24. Now let's do one last example. Let's say that you have 2 over 3 plus 3 over 5 plus 5 over 6. Here I have so many numbers. Sometimes it's just hard to find a common denominator. One way you can do it, if you go back to section 2.1, when we're trying to find the LCM, when you have a lot of numbers sometimes, what you can do is you can find the LCM that way. You always start to divide by 2. Now does 2 goes into 3 evenly? No. Does 2 goes into 5 evenly? No. Does 2 goes into 6 evenly? Yes, because 6 divided by 2 is 3. Now can I use 2 again? The reason why is no is because 2 doesn't go into 3, 2 doesn't go into 5, and 2 doesn't go into 3 here. So I have to move on to the next prime number, which is 3. So 3 goes into 3 once. When it's a 1, you circle it. 3 goes into 5, doesn't. And 3 goes into 6. Well, we already did 6, so 3 goes into 3 once. Now the thing is, we cannot use 3. So the only number, we're done with that column here. We're done with that column here. The only number left is 5. So what is the next prime number? Remember your prime numbers. 2, 3. After 3, the next prime number is 5. So that's what we're going to use here. We're done with this one, so we just have that 5 left. So 5 goes into 5 once. So your final step is to multiply these. So 2 times 3 is 6, and 6 times 5 is 30. So your LCM, which is least common multiple, is 30. So that's what you want your denominators to change into in this case here. You want your 3 to become a 30, you want your 5 to become a 30, and you want your 6 to become a 30. Now how are we going to do that? Always think in terms of multiplication. How do you jump from 3 to 30? 3 times what gives you 30? It's 3 times 10. Even if you didn't know, again, just go ahead and take this number here, the big one, and divide it by the small one. So that means do 30 divided by 3. Again, the biggest one is inside. Inside, outside. So how many times 3 goes into 3? Once. 1 times 3 is 3. Take away, bring down the 0. How many times 3 goes into 0? 3 doesn't go into 0, so 0 times 3 is 0. Take away your final remainder of 0. So 3 goes into 30 10 times. Again, remember your multiplication tables? 5 times what gives me 30? It's 5 times 6. 6 times what gives me 30? It's 6 times 5. So again, what was the rule? If I'm going to multiply the bottom here by 10, so I can get 30, I have to do it to the top as well. Whatever I do on the bottom, do it to the top. If I multiply this by 6 to get 30, I have to do it to the top as well. Whatever I do on the bottom, I do it to the top. If I'm multiplying this by 5 to get the 30, I have to do it to the top as well here. Whatever I do on the bottom, I do it to the top. So 3 times 10 is 30, 2 times 10 is 20, 5 times 6 is 30, and 3 times 6 is 18. 6 times 5 is 30, and 5 times 5 is 25. Now that they have the same denominator, what was the rule? The rule is keep it the same, keep the same denominator, don't add them, keep it the same, and just add the top numbers. So that means you're just going to add the 20 with the 18 and with the 25. You're just going to add them up. So 8 plus 5 is 13, carry a 1, 1 plus 2 is 3, 3 plus 1 is 4, 4 plus 2 is 6. Now you have 63 over 30. Now the thing is that we're almost done. The only problem is your final answer, like we said again, you cannot leave it as an improper fraction. Improper fraction because the top number is larger than the bottom. So you need to change it as a mixed number. And how do we do that again? Is by dividing. Again, remember, I over O. So that means 63 goes inside, stands for I, and 30 goes on the outside. So how many times 30 goes into 63? It's twice. Why? Because 30 times 2 is 60. So 2 times 30 is 60. 63 take away 60 is 3 left. So your final answer is, this one always goes in front. Your remainder goes in the back here. And your denominator, which was 30, stays the same. Now again, this problem was slightly more complicated because this is not the final answer. Why is that? Because we always need to make sure that we can reduce. Can we reduce here? Again, this is a 3 and this is 30. So you have 2, 3 over 30. What number can I reduce the 3 and the 30 by? I can reduce it by a 3. Hopefully with some practice you'll realize why we can reduce it by a 3 here. So the 2, that number here, stays untouched. 3 divided by 3 gives me 1, and 30 divided by 3 gives me 10. So your final answer is 2 1/10. Thanks for watching and make sure you practice. Bye.